Okay, we've got an interesting integral here, slash limit. This one's from Berkeley Math Tournament 2022, number 7. We have the limit as x is approaching 0 of 1 plus the integral from 0 to x cosine t minus 1 over t squared dt, all to the 1 over x. Okay, to get started with it, the first thing you might want to try on this is to just kind of plug in and see what happens at 0. Although, like you might guess, it's not really going to get us anywhere because like over here, we're blowing up to infinity if you plug in 0. Here, if our integral's from 0 to 0, it's essentially means the integral would be 0 except for what we have on the inside. If you distribute in, if x is 0, then t is 0, then this is an indeterminate form, so we can't really say what this is either. So plugging in is not going to really get us anywhere, but we can kind of break this up into different parts. Like I can kind of put some labels, just deal with the integral first. And so I could call the whole thing a function in x, because if you did it all the way out, x is what's going to come out of it when you plug in. So we can write this thing. And then by the fundamental theorem of calculus, we can take a derivative on it because it's just going to be like plugging in this x. So for our derivative of this function, now it's just going to become cosine x minus 1 over x squared. Then we can try to calculate a limit on just this thing here. So we want the limit as x is approaching 0 of this derivative. So this is just going to be the limit as x approaches 0 of this thing. But you'll notice, like we said before, well, we didn't really say it explicitly about this, but this is still going to be an indeterminate form. You plug in 0, the denominator is going to 0. You plug in 0 here, this piece goes to 1. But 1 minus 1 is going to 0. So indeterminate form, but that's going to let me use L'Hopital's rule on this, take the derivative of the numerator and denominator, and then we can try to take the limit again on the derivative. So here on cosine, it's going to be minus sine x. The minus 1 goes away, derivative of that's 0. Take the derivative here, we get 2x. Then looking at this limit, as x is going to 0, now the numerator goes to 0 and the denominator still goes to 0. So we still have an indeterminate form here. What are you going to do? L'Hopital's rule again. So same thing. Take another limit as x is going to 0. Derivative again. Here now we're going to have minus cosine x. Derivative of 2x is just a 2. Now evaluating the limit, it's not going to be an indeterminate form. Clearly we have a constant in the denominator. Evaluated 0, cosine at 0 is just 1. Numerator becomes minus 1, so now our limit for this thing right here is going to be just minus 1/2. And now that we know this fact though, we can quickly get to another value. We can look at what is going to be the limit as x approaching 0 of the whole function, not the derivative, this I of x thing. Well, notice we already calculated this limit at 0, just with a different variable, which doesn't matter. So this would be like the limit as t is approaching 0 of this thing, but we know what that value is. It's minus 1/2. So just to get a feel for what's happening here, kind of writing it without the limit for a second, if x is going to 0, we have an integral kind of like 0 to 0, which is always 0, but we have this thing about if this is an indeterminate form. But we found the limit on it, so we can think of the integral as 1/2. So doing this limit out, you've got like a constant finite value here, but the area under the curve, it's got no width. So it's like, so if you think about an area with a height of like a half, I mean minus 1/2, but with no width, it means that this limit right here is going to be a 0. So I think with these two facts here, I think we're pretty much good to go. Let me just kind of summarize it and we'll get to the main course of the limit. Okay, now I summarized what we found on the previous board over here to the right. I put a label on our problem. This is our goal. We want to get this y value, which is this whole thing. But then for our y value, I want to use this trick and write it a little differently. Y is the same thing as e to the ln y, using the natural log to try to help us evaluate this. So now if I rewrite it and plug in all this for our y value, I'll just rearrange it because here we'd have the limit inside the natural log. Let's bring it outside to take the limit of the whole thing. So we want the limit as x approaches 0 of the natural log of everything else, which is going to be 1 plus. Now to shorten it, we said this thing is our I of x. So we'll say this is 1 plus I of x, and this is all to the 1 over x. But now with 1 over x and the exponent in the natural log, we can use log properties and bring it out front like this. But really what I want to do is, let's write it a little differently. Let's write it like this. So then if we go and focus, not really worried about the e, we just want to see, can we do this integral right here? If you kind of plug in 0, we're dividing by 0, that's not great. If you evaluate this thing at 0, well, we found this over here for the I of x value, that's 0. So the numerator becomes natural log of 1. And so the numerator is going to 0 as well. So again, we have a 0 over 0 situation. So again, let's use L'Hopital's rule on this thing. Taking the derivative, numerator and denominator, we'll just focus on the limit right now. So we want the limit as x is going to 0. Derivative of x is just 1. Derivative here we'll do carefully, so it's going to be 1 over the inside stuff, so 1 over 1 plus I of x. Then chain rule, derivative of all this, derivative of that's 0, derivative here is I prime x. But what that's going to allow us to do is use the values that we found before, because we have these right here and here. So plugging in the limit as x approaching 0 of I prime of x is going to be minus 1/2. Here, this piece we said is this limit's going to 0, so we just have a 1 here. So what's happening is this limit right here is going to be minus 1/2. Plug that back into the exponent, and what we have is just e minus 1/2. We'll just rewrite it a little bit, flip it and bring it into the denominator. And for my final solution on it, we just get 1 over square root of e, and that's it. Okay, so there you go. Pretty tricky. I think the hardest part's raising it to e. That might not be very intuitive. I think this part wasn't too bad. So anyway, that's it for today. Thanks everyone for watching. Have a good day.